Hi everyone. Today we are starting chapter 5, so if you would, please get out your learning targets paper. There is no warm-up today, so you can just do today's date, which is the 19th, and cross out the warm-up, no warm-up, because we're starting a brand new chapter, chapter 5. Chapter 5 is all about some geometric relationships within triangles. So chapter 4, we proved triangle congruence over and over and over. Now we're going to look at some specific things within the triangles, like the midsegments, the bisectors, and then inequalities involving sides. So today's stuff, 5.1. Our learning target is that we will use properties of midsegments to solve problems so that we can prove the midsegment is parallel to the third side of the triangle and half its length. And then we'll know we've learned this when we can use indirect measurement to find the length of a bridge across a lake. And that's going to be your exit ticket. So I'll give you 30 seconds or so to catch up, or if you need to, you can pause the video to make sure you complete the learning target before we jump into our notes. Also, if you haven't done so, make sure you pick up a notes packet on the front table. Alright, so today, looking at notes for Chapter 5. Chapter 5, if you notice, it's a short section. We've only do 5.1, 5.2, 5.5. We've already done 5.4. We did that back in Chapter 2 because it fit better with the converses and inverses there. So Chapter 5, we're going to start 5.1 is midsegments. Well, since our learning target was to use properties of a midsegment to solve problems, we kind of need to know what a midsegment is. A midsegment, and then we're talking about a triangle, so I'm going to add this of a triangle, is a segment connecting the midpoints of two sides of a triangle. The midsegment of a triangle is a segment connecting the midpoints of two sides of a triangle. And then we have theorem 5.1, the triangle midsegment theorem, which says if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side, and it is half its length. So these are the main two properties. Midsegments are parallel to the third side, and they're half the length, and we're going to use those over and over to find missing lengths, to name sets of parallel sides, to find missing measures, and just to solve for variables within problems. Alright, so let's jump into example 1. So we're going to find some missing links. In triangle XYZ, which is my entire triangle, MN and P are the midpoints. The perimeter of my small triangle is 60. Find NP, so I want to find this measurement here, and YZ. Alright, so looking at this, well, if I know the perimeter of the small triangle is 60, I can set that up because I know perimeter is all my outsides added up. So I can say 60 has to equal the 22 plus my 24 plus whatever my measure of NP is. And then we're solving. So 60 equals 22 and 24 is 46 plus whatever NP is. Subtract 46 from both sides. And we get NP is 14. I also want to find YZ, which is this entire side length. To find this, well, I'm not given anything about my perimeter of XYZ, but I am given the fact that M, N, and P are midpoints. If they are midpoints, then M splits XY into two congruent pieces. XZ is split into two congruent segments by P, and N splits YZ into two congruent segments. So I'm going to mark those congruents. We just learned that if a segment joins two midpoints, then it is parallel to the third side and half its length. So looking at here, since M and P are midpoints, then the side MP is parallel to YZ, and it's half the length. So this 22 is actually the same measurement as YN and NZ. So overall, YZ has a length of 44 units. If I asked you to find XZ, which I did not, you could have done, okay, well, since MN is 24, that's half this length, so XZ is 24 times 2, or 48. That's the main property today, that the mid-segments are parallel and then half the length of the other third side of the triangle. Number 2, so we're going to now focus on the parallel aspect of Theorem 5.1. So in the picture from above, name sets of parallel sides. Well, we just talked about that side MN is parallel to XZ. I have side YZ is parallel to MP. And then last but not least, PN would be parallel to XY. It doesn't matter if you list the mid-segment first or the triangle side first, as long as you're just showing me the appropriate sets of parallel sides, I am good with that. Do notice that when these are sides, you do have to have the segment notation right here. Oh, I was wrong. 4 examples. So 3, find the measure of angle AMN and the measure of angle ANN. So I'm going to mark those first of all so I know what I'm looking on. AMN. AMN is going to be this one here. and then ANM is going to be this angle here. Alright, so looking at this, I have these that are marked congruence. I have these sides that are marked congruence. So if AM is congruent to MB, then M's a midpoint. If AN is congruent to CN, N's a midpoint, which makes segment MN is a midsegment, and therefore parallel. So I'm going to mark that it is parallel to CB. If these are parallel, then all of a sudden I have two parallel lines that are cut by a transversal, and I have corresponding congruent angles. So my measure of angle AMN is 75. If AMN is 75, and we look at this triangle here, well, these sides are marked congruence. So this is an isosceles triangle, AMN. And if this base angle is 75, Chapter 4 told us that the other base angle would also be 75. That is one that is a more of an inferring problem. If you struggled with looking at this, do not panic now. We will look at more of those later on when I return. You should be starting to get a little comfortable solving problems like 4. Find the value of each variable. Alright, so I'm looking at these triangles, and I have a big triangle and then a triangle created using midsegments. And I know it's created using my midsegments because I have all of these segments marking that these are midpoints. So, first thing I look at is I have x and y's to solve, and I look at the pair that are both in terms of x. And I know two things. I can either say, well, this is half of this, or I can reverse my relationship and say if I double this, that should equal this side length. So that's what I'm going to do. I'm going to take my midsegment of x and double it and set that equal to my 3x minus 6. So 2x equals 3x minus 6. Subtract 3x both sides. Negative x equals negative 6. So my x is 6. Okay. That is necessary because my other variable y is set equal to something that's solved for in terms of x. So again, I can either cut this in half and set that equal to y, or I can double the midsegment and set that equal here. So that's what I'm going to do. I'm going to double my midsegment, so 2 times y equals 2x plus 1. If you did this first, you would have seen an x and y, and then say, I can't solve for that. So that's why we went back and that's why we solved for the x first, because now that I have 6, it's just a simple substitution problem, and I can do, well, 2y equals 2 times 6 plus 1. So 2y equals, well, 12 plus 1 is 13, divide by 2, y is 6.5. That is 1-5, folks. You have your assignment sheet that was also on the front table. Give this your best shot. There will be an exit ticket to do the last 5 minutes of class, and then I will be back tomorrow to answer any questions. All right.